Hi everyone, this is Mr. Mohammed. Today we're going to be talking about the implicit differentiation and how we find the derivative of a relationship between two or more variables. So first we're going to consider relationships like the following. 2xy plus y squared equals 4x squared plus 3y. And as you can see, it's not the easiest thing in the world to find y as a function of x from this relation. So we have to deal with this as a relationship, not y as a function of x. So let's take a look at some of the key concepts that we're going to be discussing today when it comes to implicit differentiation and finding the derivative using implicit differentiation. So first, d by dx of x is 1. Obviously, we all know that. And d by dx of y is just like dy by dx, which is the slope of the function, or y prime. But how about d by dx of y squared though? When you come across this term, it's just like using the chain rule. So you just like drop the power of the main function 2, then times y to the 1, and then you multiply by the derivative of the inside function, which will be y prime. So it should be 2y y prime. Right, d by dx of xy, as you guys can see, x is times y, and we know that y is a function of x, so it's the product rule. So you take the first times the derivative of the second plus the second times the derivative of the first. So it should be x y prime plus y times 1. Right. One last example here, I have d by dx of xy squared, which should be 2x y prime plus y squared. Similar thing. You take the first term, which is x, multiply by the derivative of y squared, which is 2y prime, like we said, we saw here, and then we multiply the second term, which is y squared, times the derivative of x, like we saw in here. Alright, let's move on to seeing the steps of actually using the implicit differentiation. And the first step will be just finding the derivative of each term. So you just come across each term, so you have to find its derivative separately. Of course, those derivatives might include y prime in them. Right? Step 2 is to isolate the terms including y prime on one side of the equation. So you're going to take all the terms that have y prime and put them on one side of the equation. Of course, preferably the left side of the equation. And then what you do is to factor out y prime and solve for it. You just like find it all by itself. And I'm going to show you guys some examples on how we do this in practice. So the first, here's an example. Find the first derivative of the following. I have y cubed equal to x cubed minus half x squared plus 1, and I need to find the derivative at x equal to 0. But what we saw from earlier, that this function or this relationship is going to result in terms that has y and y prime. So also I need to evaluate what the value of y is at x equal to 0. And that's what I'm going to do here by substituting for x equal to 0. So I have y power 3 equal to 1. And from here, I can just find out that y power 3 is 1, then y is equal to 1 at x is 0. And that's the point at which I need to find dy by dx, or y prime, or the slope at this point. All right. So we need to find the first derivative first. So we just use the power rule and the chain rule at the same time. So it results in 3y squared y prime equal to 6x squared minus x, like we saw in previous videos. And then I'm going to go to isolate y prime by dividing both sides of the equation by 3y squared. And then we substitute with the point 0 and 1, which means x is 0 and y is 1 as given. And then we end up with the derivative equal 0. Here is example 2. Find the first derivative of the following. And here they just want an expression for the derivative y prime at no point. They just want a general expression for y prime. So we take step number 1, which is find the derivative of each term. So as you guys can see, the first term is sine x squared y. So it's going to be cosine x squared y times the derivative of the inside using the chain rule like we saw before. And then the other part of the relationship is xy squared. So again, the product rule, it will be 2xy prime plus y squared. And then step number 2, we need to isolate the terms including the derivative y prime on one side of the equation. And we have to do multiplication first. We have to multiply this green term, cosine x squared y, by this orange bracket. All right, so it will be x squared y prime cosine x squared y plus 2xy cosine x squared y equals 2xyy prime plus y squared. And then we need to solve for y, or maybe find y prime on one side of the equation. Right? So as you can see, when you do our thing here, we have the two terms including y prime on the left hand side of the equation, and this basically will result in easier taking a factor out y prime from these two terms, as you guys can see. So it will be y prime, and then we take it as a common factor. So I have x squared cosine x squared y minus 2xy equals y squared minus 2xy cosine x squared y. And that should make our job much simpler to find y prime by just dividing both sides of the equation by x squared cosine x squared y minus 2xy. And that's it. You find y prime equal to y squared minus 2xy cosine x squared y over x squared cosine x squared y minus 2xy. And if he asks to find the y prime at a certain point, you just go ahead and substitute with x's and y's in this expression and you'll be good to go.